nutritional value as shown in the chart. We have the charts right there. The unit commanders are trying to plan how many of each type of meal to carry on the mission. According to the restrictions below, each day a soldier can have no more than 12 total servings. Each day a soldier must consume at least 300 grams of carbohydrates. Each day a soldier must consume at least 215 calories. 2,015 calories. For this situation, define the variables and then write a system of inequalities to describe the constraints. Next, graph the whatever. Reason for the number of each type of serving a soldier can consume in a day.
Gracias, Priscilla. All right, so this is a real world problem. Like when you own a company such as the military, believe it or not, military is a company, and it's a company owned by the United States government. And so when they think about how can I use taxpayers' money wisely to feed our soldiers, well, they play. There's people who play with numbers to figure that out. Well, we're going to play with the numbers today ourselves. So first off, we have to define our variables. Well, what are the two types of things we're talking about?
Power bar, mini meal.
Power bars and mini meals. So what if we call power balls X and we call our mini meals Y? So we have X and we have Y. Okay? All together, we know that with X and Y, the total serving needs to be no more than what? 12. So
less than or equal to.
Exactly. X plus Y is less than or equal to 12.
I was wondering why it was
All right, and then it says each day a soldier must consume at least 300 grams of carbohydrates. Well, how many carbohydrates does a power bar give them?
75.
Okay, so 75 grams per power bar, right? How many grams does a mini meal give?
15 plus 15.
Plus 15 grams per mini meal. And we know that these two things have to be what?
Greater than or equal to.
Greater than or equal to what?
300.
300. Okay, that's our second constraint. Our third constraint is that each day a soldier must consume at least 2,015
calories.
Okay, so how many calories do I get from a power bar?
155 eggs
Plus
plus 310
Good job.
greater than or equal to 310.
2,000.
Well, if you, okay, I see.
Okay, are we good?
Yeah.
All right, so what we're going to do is we're actually going to do it by hand. We're going to do this one by hand, and we'll do the next one by graph, okay? All right, so first thing first is I have to get one variable by itself. I need to get the y in each one of these constraints by itself. And the first one, what does it come down to?
Y equals 12 minus X.
No, y is not equal to like
Y is what?
Oh, yeah.
less than equal to.
12 minus x. So I can graph that, right? So where's my starting point?
12.
At 12, and I'm going to do what at 12?
Go down.
Go down one,
Over one.
down one, right one, down one, right one, down one, right one, and so on and so forth.
Can we change this one? 8 to 12. You less than 12 and move 8 to get into it. So
Let's see if she can draw a straight line. Here we go.
So we can graph it. You can't really graph it.
Did I do it? Close enough.
Yeah.
Pretty straight, pretty straight. All right, so let's do the next one. So next one would be, what would I do on the next one?
You gotta subtract 75 eggs.
So I'm going to subtract 75x.
So you get 15. No, why? I don't know.
And then I'm going to do what?
Divide by 75.
I'm going to divide by,
15.
Oh, man. I did. Okay.
so what is this y?
Hold on, wait.
Y greater than or equal to 20
Okay.
minus 5x.
How you find 315? So do you start at on the graph?
What?
How you find that on the graph?
How do I find this on the graph?
That's no language.
Huh?
Yeah.
Oh, we're going to figure that out. That's what we're about to do. All right. Can I start at 20?
Mm,
No, I cannot. So therefore, if I can't start at 20, I need to figure out where I can start at.
Can't you reduce the X?
But didn't we already start it? Cause
Y in that case.
It's 20.
oh, we allowed to do that because we already on this. Oh, we already did the first one starting at 12.
Yeah, but we can't. Do we have a graph that extends all the way up to 20?
Can we just put an
No, but
extender?
would it be like, I don't want to say unproportional, but like, would it be wrong, inaccurate because it's not? Never mind. I don't know.
Okay.
I know she.
Well, we
okay,
can't.
20 reminders.
We can't start at our y-intercept, right? Could we start at our x-intercept?
Yes.
No.
Oh, the smaller and then use the slope. Yeah, we could do that.
We could do that, right? We could start at our x-intercept.
have to draw the full line.
Do you wonder why in your warm-up you had to go over solving for x?
Okay, so
Because in order to solve for our x-intercept, we have to solve for what variable?
Hey.
Why?
X. So side note,
I just said something.
you just did it in your warm-up. How did you solve for x?
So we're gonna have to flip the
So you
sign.
so the x-intercept is
We're not worried about the sign, Heaven. We're worried about the actual intercept.
Okay.
Okay?
Circle X.
So it's going to become y minus 20 is greater than or equal to negative 5x, right?
And then you divide by
Well,
number.
That's how you do
Oh, okay.
So where's my x-intercept at? What's negative 20 divided by negative 5?
it? Or.
So I can start
Isn't
from
it negative 4?
plus 4.
a negative divided by a negative is a.
Oh, it's a
Positive.
negative 20. Okay.
So I know that I have a point here
How do you get 0?
because intercept means that my y is 0. All right, so we could start at our y-intercept, but we can start from our
X.
x-intercept. So at our x-intercept, now we can focus on our slope. Okay? So in this case, we don't have room to go down, but we can go up 5 and left 1, right?
Wait, I thought it was negative 1 over 5.
Once you go right.
We're not this doesn't tell us our slope. We only did this. This was our side note to find our
Okay. I see, I see.
intercept. Now we can come back and focus on our
Slope.
slope.
Wouldn't it be decreasing?
Yes.
5 over right. No.
But I can, because I do not have room to go down first, I can go up and go left. So 1, 2, 3, 4, 5, and I'm gonna go up 1. 1, 2, 3, 4, 5,
And we got our intercept.
and look at that. 1, 2, and then it will keep going, correct? So here's my other line.
I get it.
Miss, how's it fun?
Oh, that line's steep.
It is a very steep line. It has a slope of 5.
Miss, how come it's 5?
Yes?
How come it's 5?
How come it's 5, my slope?
I swear it was right there.
It's with x?
Let me see.
I mean, what do you get to 1?
Huh?
Don't worry
What do
about
you
that.
get to
Tonight.
1?
What's the invisible number underneath all whole numbers? 1. Alright?
No, I thought it was them.
And then my last one.
Talking about chips.
Okay, so we have 2 of our lines, and we know now one of our intercepts, right?
Yes. It is.
What's our last one?
2.
Huh?
Y
So
is
one-
greater than.
Kayla, put it up.
What happened? You
20.
what happened?
Huh?
Y is greater than or equal to 20 minus 5.
Is it 2015 minus 150x divided by 300 and...
I know it's negative 1/2.
3 over 12 is 7.5 or 6.5, right?
What's 2015 divided by 310?
13 over 2.
Huh?
6.5.
Yeah. Yeah.
That's what I said, right?
And then this is just a half, right?
Right. Am I wrong? Or right? Excuse me. Didn't I say that? Didn't I say that, right?
Okay,
Okay.
so where's my intercept at on this one?
6.5.
Negative half x.
So I can start at 6.5, right?
Yes.
Yeah.
That's here.
Over 1 down 2.
So I'm going to go down 1, down 1, right 2.
How you gonna do it?
Huh?
Down
How you
one.
gonna do it?
Oh, I was like, what am I doing? I graphed the X and
Down 1
Uh-huh.
and right 2.
Wait.
You just
That's
got
negative,
down.
right?
Yeah.
So,
Yeah.
what, can you go to the right one and down 2?
That's what she
No. Can you go to the...
rise over run.
It's rise over run.
Or
So,
Fall
fall
over.
run.
The only
Yeah,
reason we
fall
didn't
over
start
roll.
from the X
Huh?
We didn't start from the X.
No, I'm talking about like, you can go right one and down two. Because it's negative 1/2. Right?
Okay?
Or you can go down.
That's what we're doing.
Down one over two.
Yes,
Or
Nick.
over right one. Down.
Either way.
That's what we're doing, Nick. We're going down 1, right 2. Down 1, right 2.
You can't go.
I can go up 1, left 2, but is there any left over here?
Tripping, man.
Is there any left for me to go to?
No.
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 What? I don't know. I don't know.
Yeah, if it goes missing, you know what happened.
I think I found it innocent. Right? Go ahead.
Where'd you buy it from?
I don't know where to get
She just don't want to buy me one. She don't want me to go buy one.
No, actually, Versa gives me.
Where's that everything, bro?
Versa
That Heckle has everything too. I swear they be getting stuff.
They be
That's
getting
cool.
stuff. For real. They
Heckle
be
gave me
like,
these.
Mama, they gave
Mrs. Jones, how do you shade?
We're gonna go over it.
The middle. You shade the middle.
So is that point
I know, but how do you shade the other one?
3,
You know,
5? Is that? Do you go to that point?
you just shade where they all
Okay.
intersect.
All right, so here we go. Now, shading works like this. So if I was to look at the green line, what does it say? It says when y is less than, right?
Yes.
So when I do less than, I'll end up in this region, right? Okay? For the blue line, it says y is greater than. So that means everything that is greater than, I will end up in that region too.
Do we have to use different colors?
No, I'm doing it so you can see it.
Oh, okay.
And then when it says, for the red line, it says y is also greater than. So you notice the feasible region is the region where all 3 colors can end up in based on the inequality. Okay? So that creates my vertices.
Will there ever be an equation where you don't shade the middle, you shade the outside?
No, because then that wouldn't be your feasible region.
Oh, yeah, because then they won't all.
Because it could go on forever and ever and ever.
It's over in
All right, so what are my vertices?
2, 10,
So wait, 2, 10. Where else?
3, 5.
And
11, 1.
okay, so what this tells me is that at this point, this means they could eat, one soldier could eat 2 power bars and 10 meals, right? Or, huh? Or one soldier could eat 3 power bars and 5 meals.
Or 11 power.
Or we could give them 11 power bars and only 1 meal.
I think pick 11.
They need more power.
Can I see your answer, please?
No.
Okay? Based on these combinations, they can still get fed, right?
Yeah.
They'll get fed and we'll have met all of the constraints.
10 meals.
Is this how they calculate stuff? This how they do it?
Yeah, it's a computer algorithm program for most parts now. But yeah.
Because everything is technology.
Put some numbers.
All right.
My brother said whenever you drink something there, like they don't let you leave the table until you finish your drink.
For real?
Yeah, like
It's like protein.
no, it's just a water or juice. And
Dude,
like,
stay
they don't
hydrated.
you don't have to finish your meal, but you have to finish your juice or whatever you chose to drink, no matter what. And when you're done, you flip your cup over
Awesome.
and you leave.
All right.
Facts of the day.
Here we go.
Every day we're
We learned that Michael gets disciplined in the military now. So now moving on. Now we know everything. Now I want to know if the contracted food services charges $1.25 for a power bar and $3.75 each for a mini meal. Determine the maximum and minimum cost for feeding the troops. Well, first off, we would have to figure out which would be our maximum and which one would be our
25 eggs.
minimum, right? So we know that here, if I have 2 power bars and they're each $1.25, and I have 10 meals and they're each $3.75, what's the total cost for the person here?
So you could do,
So what would I do in the calculator?
I got you. 3.75 times 10 is 37 feet each. 1.25 times 2. I could have said
so we just put it in that thing?
And what is that? No, we can't because there's only 2 variables and we have multiple options. So that's $40. So if we choose to do this is $40 a soldier
A day?
a day to feed them.
They eat 10.
Yeah, that's my normal.
Okay?
So that's how it is.
Well, we have to find the other ones. We have to figure out which is our max and which is our min. So let's do the 3-5. So if I do only 3 power bars a day, and I do 5 meals a day,
22.5.
$22.50. $22.50 per soldier. And then 11-1
It'd be like 15.
17.
17.50.
is it how much?
17.50.
Okay, so if I do 11 per soldier, it's gonna be $17.50.
We did it 22.
All right, so what would be our maximum cost and what would be our minimum cost?
Maximum 40, minimum is 17.
All right, so this is our max. This is our min. Do y'all notice the location of your max and min?
They're at the bottom and the top of the.
Do you get it now? Do you see it?
So the minimum is never gonna be either.
So this is always just gonna be the middle.
What if, you know how when you have the straight lines and there's 2 and 1 right here and 1 right here, so there'd be 2 maxes and 1 min or 2 minimums?
If they're on the same point. Okay?
But it would change
Oh,
because it's
okay.
on the other
I
number,
see.
right?
They have to
We
do
do,
work.
we do all that work
What value?
for 2 numbers.
No, we're still not finished.
We're not done. We haven't answered the question. Yes.
You gotta feed 250 people
that the one that had the half
on a 30-day mission.
No.
Oh, that just
All
happened.
y'all gotta do is do 11.
All right. So it says there's 250 troops, and they're gonna be gone for a 30-day mission. So I know that for each troop, for the max, it costs how much?
40 bucks.
250, 75.
So the max is 40 per guy, and how many guys and girls are there?
250.
131,200.
And they're gonna be gone for how long?
30 days.
So the maximum cost could be,
I got 131,250.
that's
No,
not the
that was
max.
the other one.
That's the min.
Oh, that's the min.
300,000.
$300,000 for them to feed them all for 1 month.
That's a lot of money.
But then we gotta do a minimum.
So the minimum is when we use $17.50, which
131,250.
$131,050.
250.
So the military has to decide, do we want to go the cheap route and just fill them power bars all day long?
No, cheap.
Or do we want to be the more expensive route and fill them meals all day long?
Meals.
Or
They
How
can
much-
do
they can always go in the
a
middle
little bit of both.
On the middle.
and get 3, you know.
Scared.
It actually is very
I used to have no about
So that's it?
That seems a little more logical. All right. How do we feel?
Okay.
I feel
I
bad.
really when I get home, I'm gonna.
Too much number for.
Yeah, as soon as I get home, it's gonna be gone, but other
Okay,
than that.
let's work with the calculator.
All right. Now we're going to do this one with the calculator. All right, Mark, you're going to read about the Heart of Texas Sweets Shop.
Is that over at
I don't think it's real.
Texas Sweets Shop makes pecan pies during the fall and winter months. To do so, the bakery purchases and processes native pecans from 2 distilleries, one in North Texas and the other in South Texas. The owners are trying to figure out the most economical way to do this. They know that pies must be made under the following conditions. To meet demand, the shop must process at least 35 pounds of pecans each week. Because of limited labor and storage, the shop can process a maximum of 70 pounds a week. Each shipment of pecans contains a certain amount of waste products, such as shells and leaves, that will not be used. The shop owners want no more than 14 pounds per week of such waste. They estimate that 1/6 of every pound of pecans from North Texas is waste, as well as 1/3 of each pound from South Texas. For this situation, find the variables and then write a system of inequalities to describe the constraints. Next, graph the feasible region for the numbers of pounds of pecans from each distributor they can order a week.
All right. So first off, we need to identify our variables. What are our variables?
Pecans in South Texas and pecans in North Texas.
Pecans in South Texas and pecans in.
North Texas.
Okay, so we can let x equal. How about North Texas con. And we can let y equal South Texas con.
Pecan.
You can't.
I don't like doing by calculator because then we can't graph it right.
If you find the points, yeah.
All right. What's our first constraint?
At least 30 pounds a week. Pounds of pecans each week.
So less than or equal to. No,
Oh,
more
okay.
greater than it.
It's
That's
like
the
x plus
equal.
y has to be greater than or equal to.
There you go. So we know that our first constraint is x plus y has to be greater than or equal to what?
35.
35 pounds of pecans.
So I mean,
All right. What's the next restriction?
X plus y is less than or
it
equal to
can
70.
process a maximum of 70 pounds a week.
So x plus y is less than or equal to
70.
70. And what's our last constraint?
It's kind of
1/6 of every pound.
Good job.
Say that again.
1/6 x plus 1/3 y.
We don't want to be wasteful. So 1/6x plus 1/3 y has to be what?
Less
Less than
Or equal to
14.
14. Before we can put in the calculator, we have to get what by itself?
X.
Or y.
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 All right.
y.
So for the first one in the calculator, we would put y is
Y equals negative x or 35 minus x.
I am greater than or equal to.
all right. Next one would be y is less than or equal to.
Less than or equal
70
to
minus
70
x.
minus x.
Okay. And then the last one, I'm gonna go over like a really quick shortcut way of doing this. If you put parentheses and you do 14 minus 1/6x
Oh, you just put in calculator right.
times 3.
Why you do that?
Because since we're already putting it in the calculator, there's no point of us reducing before we put it in the calculator.
Okay.
Yeah.
So we just let the calculator.
Oh, so that's gonna be our line.
Mm-hmm.
Okay.
Wow.
All right. Are we ready to put everything in the calculator?
Nope. Alright, yeah.
Anything missing? Here we go. Home calculator. We're not talking about equaling anything. So greater than or equal to
35 minus 10.
35 minus x. We're going to arrow down because we're not done.
What the heck? Mine didn't grab.
Mine's gonna
I didn't either.
Mine didn't
Oh, it's because our graphs only go to 10.
Yes. That's why we're going to put them in and we're going to go over the window.
Crap.
Don't freak out.
Oh, my God.
Thank you.
Looks good, bad, big.
Let me do this.
Kulo.
Don't say it.
What was the other one, guys? The last one? 14?
Wait, no, hold up.
times 3
Thank you.
in parentheses.
Whoa. I did something.
All right.
The whole string go blue?
Yes. Does your whole screen go blue?
Yes.
All right, let's look at our paper. We're going to go menu, 4, 1.
Hold up.
Wait.
Menu, 4, 1. And we're going to set our window. On our paper, what is our X minimum?
70.
Our X minimum?
0.
0. What's our X maximum?
70.
What are we counting by?
Wait. What are we putting?
Menu, 4, 1.
5.
All right, what's our Y minimum? What's our Y maximum? And what are we counting by?
5.
X scales 5.
Hey, you push your pen?
Yes, but I'm going to wait. Raise your hand if you need help getting to this window.
Menu for 1.
What does that mean for one?
So,
Menu, 4,
how you know your Y minimum is 0?
If you're here, press OK. How do I know my Y minimum is 0?
Yes.
For those
I don't know.
Whoa. Feel it?
It's like a big stripe.
Did you change your window setting?
You talking about this, like this? Yours like this?
Or 7.
1.
Yeah.
0, 7, 5.
And we can move
That's
it.
fine.
It's big.
It should look like a stripe, like it should be someone's flag.
Let me see. Y'all.
I don't look like a stripe.
Oh, mine don't look like that.
You see?
All y'all look the same.
Y'all did something wrong.
See?
Oh, don't.
Maybe I did something wrong.
I have what you
I
have.
did something wrong.
Well, wait. What do I have? Yeah. Someone did.
Right. Wait, no. Or
How do you get the intersection?
You just need to move your thing
It's
up
like
here.
this.
How do you get the intersection?
Me 6'4".
I'm sorry.
Sorry about you.
All I did was plug it in.
Let's see what Noe plugged in. You forgot X.
Oh, really?
Mm-hmm.
I did something. Wait, I plugged in one more thing. I mean, I plugged in an extra line.
Let me just start over.
All right. This is what your Y's are. All right. This is our region where our answers lie. So this problem has 1, 2, 3, 4, 5 solutions.
5?
Sorry, come.
Oh,
Can
dang.
you point to
I have, okay?
Oh.
I'm going to turn off the light for a second.
Oh, you booty hurt.
How do you get zoom out?
Getting booty hurt. You getting booty hurt.
I like it.
Booty hurt.
I like how I calculated book.
Okay? All right. So when you look at the window, this is my
Hey,
answer, my feasible solution, right?
feasible solution.
So I have 1, 2, 3, 4, 5. I have 5 possible values.
That doesn't end.
Huh?
No, it doesn't end.
It stops right here. Because in reality, can you make negative pecans?
No.
Oh, no.
No.
It looks like that. It's just not the same.
All right. So here we go. How do we find the intercepts?
Menu 6-4.
Menu 6, 4.
Menu.
So can you use
says
the axis as one of the lines?
Can you? It should.
Which one did you click down and which one?
So, but that's gonna give you a negative, right?
I didn't mean to do that.
How do you zoom out?
Which two did you click?
What? No.
Oh, yes.
Where?
We didn't put those restrictions in.
Restrictions.
The fact that we can't have negatives.
So how do you do that?
Hit tab, guys, and we're just gotta put in y has to be greater than or equal to 0, and x has to be greater than or equal to. No, stop putting down the calculator.
When you put the y has to be greater than
Wait,
0, you
no,
press
don't click it off.
X has to be what?
Greater than or equal to 0, and y has to be greater than or equal to 0.
you press equal after y is greater than or equal to 0 or down.
Mine
Down,
was
so you
doing
put in the
something.
x one.
Okay, this is what I'm doing.
Now show me the chart.
And then you do.
my lines are gone.
Does it look all the same blue now?
Yeah.
Is it that one that you're putting on there?
My lines
Which
are
one?
I'll not look at this.
Yeah. Mine is dark.
Like this?
Yes.
You can barely tell it apart.
Mine is dark.
I calculate black. Whenever I do meetings, or I don't know how to do the graph. Like, whenever I click on the graph.
Okay. So when you do, you take the cursor, click on it. And then
On the line.
yeah.
I don't know what I did.
in my hand.
Alright. Can I hit enter? So now I can actually find my values. Just really quick, guys. Just grab any space so that we can move our graph a little bit. And the reason why is so that when we do the Y right here, we'll be able to click on the line. Okay, so you're going to go menu, 6, 4. I click here.
Where?
On the graph. And I'm going to click on the other graph. Click. It's hard with this thing.
I just moved it.
Okay.
Is my X not graph?
Which two lines did you click?
The X axis, the Y axis.
I just moved it, but it makes sense for me.
I know. Oh, I didn't graph my X. I personally think some things are better by hand.
Yeah.
Like this. I mean, if you know how to do it.
I mean, there's always that little, did I graph it right? Did I?
Yeah.
All right, here you go. Click, click, top, bottom. So this one's at 0.35. Menu, 6.4. Click, click, top, bottom, 0.42.
You saying there's no, wait.
Remember, I just told you may have to move your graph a little bit in order to be able to click on it.
I can't.
You click into an open space and you just hold it down.
Oh my god, I can't do it.
Menu, 6.4. I can do the X and the Y.
5614.
Click, click,
I just keep saying,
left, right. I'm coming.
I got negative 14, 49. Negative 14.
I'm getting the same answer.
Thank you.
Where it's darkest.
350, right, is one?
Yeah.
I'm coming. I'm coming. I just want to finish.
And 5614.
And then last one 70, I believe.
And then the last one, menu, 6.4. Click. And my last one was, I can't see it.
Negative 9, 19.
Is that,
It can't be negative, right?
it can't be negative.
Wait,
What it said. Maybe it was 9, 19.
I think when you were trying to click the line, they was doing upper bound and lower bound when you were trying to click the line. So
OMG. Skittles. Alright, I need to move this label out of my way. I need to move this label out of my way. Alright, let's try this again. Menu, 6.4. Click, click, left, right. I remember getting 70 earlier.
I got 72.
So let's just do 70.
It's 70. I think I may have moved my line.
79 good.
But it would have changed the rest of them, right? It was just that one.
I don't know. We'll go with 70.
I got 70.
You can't have 0.8 of pecan. Alright. Now.
Oh, that's hard.
Is that us?
Yeah.
Shoot me in the face.
For real?
Oh my God, that was fast. Alright. We're going to have to, I guess, work over the classwork tomorrow.
I mean, I don't know what I was trying to say.
You have your take-home quiz. Your take-home quiz is